cat interviews at Uber, Confluent, Indeed, and many more companies. I've seen it all. After countless hours on the other side of the table, I know exactly what top companies are looking for, especially in NLD. In this course, I'll share the insider blueprints, what to focus on, especially key design patterns, how much multi-threading, very important, counter question, traps, and how to tackle them confidently. This course is structured, practical, and tailored on what companies are looking for right now. Let's get you interview ready right now.
So in the last videos, we saw about introduction to LLD, interview tips, and OOPS. Now in this, we're going to see about solid, which is single responsibility, open closed, Liskov substitution, interface segmented, and dependency inversion. We'll see about try, don't repeat yourself. We'll see kiss, keep it simple and stupid, and we'll see YAGNI. Yet you aren't going to need it. Now, before we go on, why they are useful? See, software development is a very complex field, right? And it needs very careful planning. Again, all this we saw previously as well, right? Even if you want to make something abstract, right, you have to do a careful planning so that you are not overestimating or underestimating the actual work needed or actual task to be done. And obviously, whenever I say any task, I'm referring a design, LLD, low level design or low level code for it to be done, which needs to be done because I have to maintain scalable and easy to understand code. Why it is useful? Because these set of guidelines are kind of the foundation guidelines and especially solid principles. See, these are just some set of things. Okay, do like this so that the code is something of this pattern, and you are not repeating things, you're keeping things simple, as we saw also in oops, a bit of here and there. But primarily, solid will help you to actually achieve maintainable, scalable, and easy to understand code. The biggest thing part is that things will be scalable, because scalability is the entire thing, that what everything you're studying right now is only because you want things to be scalable. Other thing is maintainable, because you know that in a firm there are a lot of people who work, and obviously you will go, someone else will come and work. So things should be made such that they are maintainable, and any changes in any part of the system should not impact any other part. Why it is that? Okay, even if it is impacting, it should have a very minimal impact, because even if let's say there's one system having many components. Now if let's say they are very tightly coupled and you have written test for all of them, so if you change one of them, then obviously everything else will be impacted. And as the code base grows, if you write a tightly coupled system and you have written the test for it, you do any small change and it will impact the entire code base. And that's going to use a lot of your time, and ultimately the effort by any person who will write or touch base that code will be immense. Next thing, testability. Same way, that because we have that design which we will do, we will have a decoupled design which will help us in more and better unit testing. Lastly, readability. Obviously, separation of concerns help us to actually read the code easily and have more better structure. Okay, this is individual component, individual component, individual. So all these are individual components which you don't need to interact with each other directly, or have very tightly coupled with each other. I can simply go ahead and make them loosely coupled and work on them. So ultimately, adopting these solid principles and also different design principles is actually a very important step for clean code and also professional software development. Now, next we'll see the first one, which is single responsibility principle. Okay, so now starting off with single responsibility, as the word itself says, single responsibility, which means the class should have a single responsibility, which means that every class should have one job or one purpose. That's it. It helps us to improve the maintainability and enhance the readability. How? Let's see. So, for example, we have a baker. Now, his task is only to bake the bread, which means that we want him to bake the bread of very high quality and do it perfectly. But if we in the baker class also write, managing the inventory, ordering the supplies, serving the customers, cleaning the bakery, so technically, if we write all of this thing, it will not impact. Okay, I can still have a class which can still manage it, but ultimately it will reduce the efficiency of baker as well as the readability. Because ultimately, if I'm saying managing inventory, how is baker responsible for managing the inventory? It doesn't make sense, right? Yes. That is the reason Basically, we are saying that each task represents a separate responsibility. So all these things are separate responsibility. And we want the baker's focus and effectiveness in baking the bread. And I don't want to compromise that thing. So what to do? Before that, let's see how the bad code looks like. A bad code simply says, okay, I have a bread baker. Let's say it's a class. It can bake bread, manage inventory, order supplies, serve customers, clean bakery. Still, you can see I can make a baker object and I can still call all of these methods. It's perfectly fine, it will work. But it violates single responsibility because my baker technically is doing everything. If in future I want to do any modification in inventory, I will unnecessarily have to modify this bread baker class which is unrelated to it, right? That is the thing, that we are saying the class should have a single responsibility. Because again, what happened because of the above code? Obviously, as we see that it reduces the readability. I unnecessarily have to go through other things, what exactly is happening. If I only want to cater about, manage inventory, why I'm looking at, bake bread, all that stuff. If I only want to look at bake bread, because that's what the baker will do, why I'm looking at inventory and stuff. So ultimately, I am reducing my readability. Obviously, the complexity ultimately will increase. Increasing complexity is directly proportional to reducing the readability, and obviously making the debugging very, very difficult. Because what will happen? You will have to come inside, and again, this thing is very simple. It can literally become very complex. This I have just put up one method. I can literally have many, many, many methods. And if you want to just debug, understand things, it will be pretty difficult. Just to understand the code base itself will be very difficult. So, what to do? Simply do one thing. Baker will bake the bread. Inventory manager will manage the inventory. Supply order manager will manage these order suppliers. Customer service will serve the corresponding customers, and baker cleaner will clean the bakery. So, I have given these people their corresponding individual task, and that's what they will do. So, bread baker will just handle the baker bread. Again, it can need other helper methods as well, which can either reside in this class or maybe in the same package in some helper class. That's totally how a production code base works. Then, same way, I have inventory manager. I can manage inventory. Supply order, which will order supplies. Customer service, which will serve the customers. And baker cleaner, which will clean the bakery. And thus, I will make individual objects and can cater all the functionality with the help of individual objects. Thus, what you see, obviously, with that, the code is now more maintainable. If I want to change or do any change in inventory, I only have to touch that piece of code or that piece of class. That's it. It is easy to understand because the wording itself says that okay, manage inventory from inventory manager itself. So I can come down and just simply ask, okay, bro, what's gonna happen? Obviously, inventory manager can have something linked to it, which will manage the inventory. It can be, you know, just having a check on the inventory, just having updating inventory. There are multiple things which inventory manager can actually perform, and the word itself says that okay, it can handle the inventory stuff. Next thing, the changes in one class do not impact the unrelated parts of the class. Obviously, if I do any change in the baker, none of the other ones will be impacted. Next one, it will enhance the readability. Obviously, the complexity is reduced, maintainability increased, readability is also increased. Next thing, each class has clear and focused responsibility, and that's the main purpose, single responsibility. You have a focused and clear responsibility of what thing you have to perform. Lastly, the thing will be more modular and easier to manage. The biggest part is things will be much more easier to handle, test, and change in future because this is a very small piece of code. Individual classes will literally extend like anything, and that's when you realize that it's good to actually give individual tasks to individual classes. And that's how you know that you are maintaining single responsibility. In the next video, we're going to see open close principle. We have open closed principle. As the word itself says, open for extension, which means extending a specific code, but closed for modification of the existing code. Again, it can be a class, module, functions, anything. It should be open for extension but should be closed for modification. I will try to actually extend the behavior and should not modify it. Why? Because obviously it will prevent breaking the existing code. Now you might say, Aryan, I understand the existing code, I will do some changes to it, and then I will just simply merge it. Okay, you understand this. But imagine in future, any new person comes in, he doesn't understand the code. Now you might say, Aryan, no worries, he will do the changes, then he will run the test. Okay, but he will run what test? He will run unit test. No, Aryan, he will run unit test, he will run system test, he will run, different tests. He can run integration test, he can run market test, he can run. So he will run multiple set of tests for it. And then he will be able to figure out if that code impacted your existing code or not. Isn't it a lot? Because obviously, to run the entire pipeline to build a normal project, it takes usually 1 day. And 1 day you are wasting just for a small change. That's gonna add up a lot. Which means it will help you prevent breaking the existing code. Although you might argue that Aaron, no, I will not break it. But again, neither your reviewer will approve it, nor it is feasible or sustainable to have changes in the existing piece of code. And again, making the code more reusable, that is the entire crux of any change or any LLD which we are studying right now. So what we'll do, we will simply extend it. And again, I said mention, I will try. That is the biggest word. Not everything can be extended. Not everything can be made new. Some things needs to be changed in the existing code, but many a times we can make a structure such that we are making a new piece of code. So let's take an example. I have a shape. In that, I have to find area. So I simply took a if condition. You know how we write in simple DSA, that if it's a circle, just find the area. If it's a rectangle, find the area. Now in the future, I ask you, get me a triangle shape. What you will do? You will have another else condition, right? As simple as you could do. But again, the main issue is that whatever test which you have written for this, right? It would need to have another impact of this triangle. Now, in this case, it is very simple, straightforward, because any change you do is not impacting anything else. But, and it's a simple else if, but things are not necessarily straightforward. It can actually impact multiple other things in the code. And that change could impact many things. So, the base issue it leads to potential bugs. Again, I'm not saying actual bugs, but potential bugs. Other very wrong thing is things are being more tightly coupled. So you are very tightly coupling up the entire thing, circle, rectangle, triangle. In future, if I ask you calculate the height, you might end up having another function and another coupling inside it. So you see that it's just one thing you do wrong, and then everything needs to actually follow the same format, and then the things keep on going wrong. So what we can do is we can have a better approach, that we can have an abstract class or an interface. Now, if you are confused on what to choose, go back to the OOPS course. In that, we discussed in very deep about abstract class interface and when to use what. So what we can do, okay, we can have a circle which will extend shape, a rectangle which will extend shape, and a triangle which will extend shape. And I will ask them to individually override the calculate area method. So you see that this was the old piece of code. I did not touch any of the old piece of code. I just made my new piece of code. And again, as I mentioned, I will try, because there are some changes. Let's say you might say, Aryan, to find the area of of triangle, let's say the logic changes. No worries. For that, I will use strategy design pattern. Finding the area, I will give a strategy to it rather than just finding hard coding. So again, I'm not saying this is a perfect piece of code which I've written here. No, but it is following open close principle. Again, if I have to make it much better, I would have passed in the area strategy, that how the area should be found. With that strategy itself, I would have found the area. There are multiple improvements which can be done, but the essence of this example is just showcasing that how open close principle will work here. Cool. So what we did, obviously the code is now more maintainable, because now you have to only maintain those individual components, just test them out individually, and then you know that anything you do does not impact anything else in the code. It is easy to understand. That's the biggest benefit, because obviously you have much more concrete implementation of triangle, and everything for triangle will lie inside this specific class. Next thing is it does not require modifying other things, or especially other existing code. This is very, very, very much required, as I mentioned earlier as well. The code reviewers itself are very reluctant in, approving a PR if they see that you have modified the existing piece of code, because it actually always have a risk of, getting things wrong. And again, the time is the biggest currency here, because if you get things wrong, it can actually be figured out in, system test and regression test and stuff, but still it takes time to run the entire build pipeline. Now, lastly, it obviously prevents breaking the code, that's one thing, but it gives us reusable components which I can reuse another for more extension in the existing piece of code. Cool. I hope you guys got this open close principle. It is very important and gives us the flexibility to actually say that, okay, I'm open for extension, but I should not modify things, which means I should be closed for modification. Let's see next Liskov substitution. Now we have Liskov substitution principle, as the word says, substitution. So it says that the child class should be able to easily substitute the corresponding parent class seamlessly. Why Liskov? Because it was introduced by Barbara Liskov in 1987. Now, it easily, again, as the word short form says, the child class should be substituting parent class seamlessly. There's a word seamlessly that has importance. We will see just now. But yeah, before that, the benefit or why it actually matters is because it gives us that reliability when we use polymorphism. If you don't know what it is, just make sure that you watch or have watched the oops section. And obviously it avoids that unexpected behaviors. Why that seamlessly word was used just because that we don't want any unexpected behavior. Let's see as an example, we have a vehicle, right? Then we have a car which extends the vehicle, kind of, extending, following our open close principle. Then we have bicycle, okay, again extend the vehicle. Now we have a method called a start engine. Obviously he has to implement it. Car implements seamlessly, car will start the engine, but bicycle doesn't have an engine. Or I should say, not necessarily all the bicycles will have an engine, because again we can have electric bicycles right now, but still, even if some motorized bicycle come in, that is also a motorbike, not a bicycle. So obviously we have to handle it, which means either I have to write some implementation. Obviously there's no implementation as such, so throw an exception. Now you might, again, if you are a very junior engineer, you might think, Aryan, I will just write a simple s out statement, just printing up that, okay, it is not possible. It isn't how it happens in a production code base. If something is not valid, you throw an exception that, okay, this is not valid. Simply exception is thrown so that the program doesn't run any further for it. And again, there's no if conditions, you are right for the same things, you just throw an exception for it. So basically we realize that bicycle technically is not a substitute for vehicle. So I cannot replace, let's say for example, if I have a function name XYZ, I have a vehicle in that and I just simply pass in a vehicle. So this is a vehicle. I cannot pass in bicycle. Now you might say, Aryan, you can pass in because bicycle extends vehicle, so you can simply pass in bicycle as well. Yes, you can do, but you will start calling vehicle dot start engine. And with that start engine, and with that thing, you will see that as you call this, if it's a vehicle type, you will call start engine, it will throw an exception. You have to handle this exception literally everywhere you write this. So you see, unnecessary piece of code, and this is just I have written in the main function. Once you will write the same thing again and again, many times. And that is the issue. It will make the code very untidy. I'm not saying that we don't handle the exceptions. We handle it. But unnecessarily handling of things because the structure was incorrect, it is not okay, right? That is the reason we realize that it leads to basically, again, when the subclasses cannot fulfill the contract of its parent classes, obviously it leads to breakdown in polymorphism. That's the one obvious side effect for it. And the other thing is that the code becomes inflexible and also very hard to extend, because right now, even if I have, let's say, another thing in future, I have a cart, right? A cart, it also a vehicle. I cannot extend vehicle, I will again have the same issue. So obviously that it is kind of again and again the issue can come up. And obviously everyone will be forced to implement the start engine, which is not okay, which ultimately brings us to the fact that it reduces the modularity and reusability of our code. which is not the spirit of LLD. LLD says that I should have more modularity, more clean code, more reusable piece of code, which is kind of violation if I'm not able to substitute my parent easily. So how to go about this? Obviously, we can have engine vehicle or a non-engine vehicle. How? Obviously, I can have a vehicle, again, as abstract class or as an interface, totally up to you, or based on the requirement you have. I can have an engine vehicle and now I can have a non-engine vehicle. So car will extend the engine vehicle, but the bicycle will extend a non-engine vehicle. Now, because of this, I now can simply call bicycle.move because now it has a move method which comes up from the vehicle. As simple as that. Now, what will happen with this? Obviously, in the future, I can have cart, I can have any of the non-engine vehicle which will be there. And again, any functionalities of non-engine vehicle, I can put up in non-engine vehicle. And again, if I think there are functionalities which are common to engine and non-engine, I can put up in vehicle, simple vehicle, this one. Cool. Now, how it helps us? Obviously, this child, which is the bicycle, can now easily substitute its parent, which is non-engine vehicle, right? And that's the beauty of it. So how it help me? Basically, each subtype fully satisfies the behavior contract of its parent type. And that's the beauty, that every subtype can now seamlessly substitute its corresponding parent. And also, again, the inheritance hierarchy accurately models the real world domain, because obviously you have engine, non-engine, vehicle. So that hierarchy which you have, now you have vehicle, engine, non-engine, and then engine you have car, bus, truck, then you non-engine you have cycle, cart, and all that stuff. So this is now actually representing the actual hierarchy. So if we are moving close towards what actually we have, and that is what is Liskov substitution principle, that your child should be able to seamlessly substitute its parent. Next, we will see interface segregation principle. So now we have interface segmented principle. As the word itself says, this is for interfaces only. So far what we saw was for classes, but this is for interface rather than the classes. What is segregation? As the word itself says, segregates. It segregates the interfaces based on the functionality, which means that I will avoid the fat interfaces, just clubbing everything in one interface. No, I'll not do that. I'll segregate the interfaces based on their functionalities. So even if you have one interface having multiple functionalities, no, I will segregate them on the basis of their functionality. That is what is interface segregated principle, which ultimately means that it does not focus on like it does not force any client to implement an interface which is irrelevant to them. Obviously, if I will just bloat it down an interface, if I will bloat it down to with multiple things, I will have to force the client to implement literally everything. But if I will have individual interfaces, then the client can choose what he wants to implement. And that's why it is used. And why does matter? Like, why does it matter? It matters because it reduces that unnecessary dependency. If I will not bloat it, if I will keep as and what is required in each interfaces, I will have I will not have any unnecessary dependencies. And also it simplifies the implementation, because you no longer have to implement things which you don't need. Now, let's take an example. For example, you have, a simple machine interface. Now, it, let's say, is a machine. So, printing, scanning, faxing. Now, you made this interface thinking in mind that you will want an all-in-one printer, but then next time you wanted a basic printer as well. Then unnecessarily, you will have to implement scan and fax implementations. For example, you had this machine which can print, scan, and fax. Now, you designed this by keeping in mind that you will be having all-in-one printer. But then next time, you just needed a basic printer. For that basic printer itself, you would be needing to override scan and fax methods. Is it good? Obviously not, because you will have to throw an exception. As I told last time, like in the last sections as well, we saw that throwing exception, which means that wherever this is being called, it needs to be handled separately. And that's an issue. That's a burden. That's literally an overhead for maintaining these two methods. Although in production code basis, sometimes we do it, but still, it is not a good practice if we can ignore it. So it's kind of, you know, I'm burdening you with the irrelevant methods which are not that useful. And that's the thing, that the code becomes less flexible and also very hard to extend. Obviously, in the future, if I want to have another kind of printer, I will still have to implement all these methods, which is, a pain. And that's the thing, that any new functionalities, are added to the machine interface, all the implementing classes need to have that functionality. And even if it might happen that they might not require that as well, which ultimately means that they will create unnecessary dependency and the code becomes very tightly coupled. Now, with the help of interface segregation principle, which says this is for interfaces and we will segregate the corresponding interfaces based on the functionality, I'll create smaller, more focused interfaces. That's the entire essence of it. How? I will create a printer, scanner, fax machine interface. Now with that, the basic printer will only implement the printer. An all-in-one printer can implement multiple interfaces. That's the beauty. So with that, I only implement what I need. That's it. And it will prevent us to have any dummy implementation or giving or passing any exceptions and all that stuff. And that is the beauty which we can actually take. So what happened, that each interface here actually follows a specific responsibility, and it leads to better cohesion and separation of concerns, because now things are separate and now we are good to go. So ultimately, by using segregating interfaces, you can simply ensure that classes only implement the methods that are relevant to their functionality. This is very important both in terms of actual design and also the normal functionality of any specific class. I should keep only the things which are relevant to them, and it will lead us to more robust and maintainable system, and obviously these will be scalable as well. Next, we'll go on to dependency inversion. Now we have dependency inversion principle. It says that you have to depend on interfaces rather than the concrete classes. When I say interfaces, I mean the classes should depend upon abstraction, which means interfaces or abstract classes, rather than depending on the concrete implementation. Why? Because it will help us to promote decoupled architecture. Things are decoupled and I can just integrate whatever I want, and also it will facilitate better testing and maintainability. This is a very important thing, that you should always make sure that if things are more decoupled, they are more better tested and better. Again, if you can inject things on runtime on the basis of any other thing, which I will show just now, with that you will have a better testing framework in place. This has been asked to me as well, that what will you do to make sure that you have better testing. With that, you will have to ensure that you are following dependency inversion. Now let's see an example, that we have an e-commerce system. Now in that we have different type of notifications which we can have, customer, administrator, inventory, and so on and so forth. So what you might end up doing is that you have email notifier, which will have a send email function. Again, you can have its own implementation based on SMTP, and you'll configure this, all that stuff. Now in the actual order service, you will simply have a constructor in which you can do something of this sort. Okay, email notifier, I'll just simply get the email notifier, logger, inventory. Did you see something very bad here? This is very hard coded, like this is very tightly coupled. If I have to in future change the email notifier to let's say notifier, I just want a simple notification, right? Maybe I wanted to change it to SMS. Then I have to come here and change this. With changing this as an event notifier, because right now it's no more event notifier, it is now SMS notifier, entire class will change. You see that how tightly coupled it was? It was very, very tightly coupled. And that is the reason it is also hard to test, because now you cannot pass any of the mocking to the constructor. No, the constructor will itself make its own classes, and maybe you can use power mock it and all that stuff to mock the individual things rather than passing it from the test itself. Another thing, that as I mentioned, if I want to do any code changes or any business requirement change, let's say now I want SMS notification, or now I want let's say Yahoo notification, then obviously the entire class will end up being changed. That's the biggest thing. And obviously, as we say in the same lines, that different notification strategies will be there, and that will cause an issue. So how to correct this? Obviously, we will use interfaces, or you can use abstract classes as well. How? Let's see. So we will have an interface, notification service, which has a simple work of sending notification. Now I can have an email notifier or a SMS or a push. Can be anything. I'll just implement their
I'll just override those corresponding send notification methods. And now inside my order service, I will have a constructor which will say, bro, get me what notification service you want. It's an interface. It's an interface. Now, calling function can call with any notification service. It either he can call with email or SMS or push. It's based on the calling function that what he wants to pass here. And that's you will also see that we are passing email notifier and this is what we are passing to it. So it is very obviously it is very less. I mean, it is not tightly coupled now. The testability is very high now. I can simply go and call and initialize all this from my test as well. Flexibility increases because in future, if you want to extend it, you can simply do it because now you just have to implement some methods or some classes, and those classes can now be passed here. Obviously, maintainability and scalability also increases because now you can easily maintain this piece of code because this does not need to change. And if does not need to change, scalability also increases because now you have different set of classes which you can keep on, implementing, making, and all that stuff, and just keep on clubbing it. Okay, if you want a different notification or if you want a different logging service as well, then you can just make another class, implement this logging service interface, and then pass it here. And that's how you can simply get maintainability, scalability, readability, flexibility, testability, like every ability you can think of is achievable. And this is a very important principle. So make sure you know that part. Next, we will see dry principle. Now we have the dry principle, which is don't repeat yourself. What it means, it will obviously avoid repetition, which is duplication of code. Whenever we reduce a duplication, we are avoiding redundancy and also promoting efficiency because one thing will be written only once. What it says is you have to create reusable components. It can be functions, modules, or even constant as well in different parts of your code base. And it will help us to minimize the chance of errors because if you make anything just once and different people are using it, if anyone figures out there's an issue, he will change it at this place only and this will correct it for literally everyone. And not individual people have to go and correct their own implementations, and that's how reducing the redundancy, which means obviously advantages: code reusability, maintains and updates are much more easier, readability increases because now it is at one place, concise place, and that's it. And I'm eliminating that unnecessary repetition portion, which obviously will make readability very, very bad because obviously if I have repetition, I will unnecessarily be bloating up my code base with seeing code again and again, and that's an issue. Obviously, consistency will be maintained because each and everyone will use one common consistent piece of function, module, or class, and that is the source of truth for everyone else. It will have reduced development time because if we let's say put up at one place, other people can come up and simply use this as a black box as well. So they don't have to implement it by themselves. Obviously, whenever we say that multiple people will use it, obviously you are collaborating and you can make it a different project, or if it's at same team then a different module. There are multiple ways to go about it. Now next is obviously it will avoid copy pasting of things, and testability will increase because now you can test this individual components separately as well, so that individual functions or individual these functionalities can be tested along with this common functionality can also be tested separately. Now, an example that how will we implement dry principle. As we saw that we can use functions or methods just so as we are not repeating ourselves. For example, if we have simple function in which I have to swap two things, here you can see I'm simply writing a swap by myself. It is not dry friendly because it's repeating the same logic. What is dry friendly? Dry friendly is just get that logic at one place, and then now I can simply call this function, swap, and I can pass in the numbers, swap. And with that, I can use the same logic at multiple places. And again, if it is used across modules, across packages, okay, you can just separate it out as a helper function as well. Now, next is I can leverage OOPS principle. As we saw previously in the OOPS section, inheritance, polymorphism, interfaces, we have literally many things with which we can actually make things more concise, more friendly, and more reusable. Same way I can do here that, I have, let's say, class, cancel button, and a submit button. Now, whenever I'm trying to call a on click, you see that I'm kind of repeating this. And let's say this is not even a thing. Let's say if I have some common functionality, animation. Now, animation, let's say I'm keeping same, both of them. Still, I will have to duplicate that animation piece of code here also and here also. And that's an issue. And that's actually a big issue. So, how will we correct it? We will correct it by simply saying, I will make an abstract class. And in that abstract class, I will have that piece of functionalities, functions, implementations, render animation, render graphics, which can be same for both cancel and submit button. So for submit button, when it will extend this button, it will have render animation functionality implemented already, and it doesn't have to duplicate that piece of code. Same way for cancel button as well, it doesn't have to duplicate that piece of code. And again, the piece of code which they want to overwrite, they can simply overwrite that by themselves. If they want to cancel, cancel. If they want to submit, submit. So it's liberty. If you want to change, change it, but unnecessarily don't duplicate it. And that's how I can achieve that specific non-duplication or dry. Next, what we can do, obviously the same thing which you saw above, we can create some reusable components. As we saw, it can be render graphics, render anything. So I have a button, simple class. It's not even abstract class, it's a simple class. But now I can extend this and I can make maybe or leverage this thing. Here I can submit or cancel. I can have multiple types of button which I can have. Same way again, you can achieve multiple. You can achieve the same thing in multiple ways. It's just that how you want to go about it. The entire essence is that you avoid duplicating piece, and that piece can also be hard-coded values, which means that you might see many times that you hard-code some values. For example, base URL, which you might hard-code like this, but it's not good because everyone else have to hard code this. And in future, let's say my company name change from example to, let's say, arent, then in the entire code base I will have to change this thing, which is very hard. Rather, if I will use constant, then I can change just at the constant place, and thus I will be good to go. So you see that how easy it is, that if I just keep things at one place and reuse it rather than everyone writing the same thing again and again. That's the entire essence of dry itself. So with that, the advantages of dry will be efficiency increases, maintainability is very easy, scalability obviously is very high, consistency across different modules, projects, packages is pretty awesome, collaboration obviously increases. Some of the disadvantages which we also have seen while we were discussing abstraction case, in OOP section we saw that over abstraction of anything can be very risky, unnecessarily writing very large piece of code and over abstracting things, which means it needs proper thinking before actually writing corresponding low level design code. And that is the reason it needs some sort of time investments from your end. Obviously they can be misuse of it, which is kind of linked to over abstraction and just overthinking of things, that like the things which are not even related, you are trying to club it together, and then in future you might actually have issues with it. And same way, if you plan to refactor your existing piece of code, you will be in pretty big effort or big backlog, because it took us around 1.5 years in Goldman to actually refactor an existing legacy piece of code. And again, it was a very big code base, but you see that 1.5 years is very large time. Ultimately, as a conclusion, obviously, we see that dry promotes readability, maintainability, and code efficiency, making sure that thing is written once, easy to read, easy to maintain, just maintain once, and also easy to change as well. And obviously, there are very less chances of errors, because if there is any error, I will just change it at one place and it will be corrected everywhere else. While if everyone else would have their own implementation, then they think, okay, I will change it just mine, but it is impacting still others. So other people, they will inform and they will change again. So manual effort increases, and also the possibility of errors impacting multiple places also increases. And that's the thing, that there are less chance of errors when it is maintained at one place and also looked at by multiple people at one place only. Obviously, this is everything in conjunction with all other principles which we saw, which means solid and other principles which we'll see next also, which is KISS, YAGNI and stuff. All these in conjunction makes that development reliable, scalable, and maintainable. It's not just one thing, one principle which can do everything. No, it's entirely a mixture of different principles. We saw that entire solid right now. We will see about KISS, YAGNI. All that makes your entire development more robust, more scalable, and more maintainable. Cool. Let's see next YAGNI. Before that, we'll see KISS. Now we have KISS. Not that KISS, but keep it simple and stupid. Now,
As I said previously as well, that simplicity in design implementation is a very key thing. That you don't overcomplicate. We saw that in abstraction as well. But with that said, there is a very thin line between scalable and maintainable code and overcomplicated code. And it's very hard to know that you are at this stage or this stage. But there are key things which can make your code super overcomplicated. And we will see that with the help of examples below. But making sure that KISS principle says that solution or systems, anything whatever you make, should be as simple as possible, like literally as simple as possible. Because overcomplicated code is harder to understand and also debug and maintain. Like literally can't even imagine that how much effort it goes in just understanding, approving, maintaining an overcomplicated code. Obviously it improves your own productivity as well as others as well. Let's see an example of a overcomplicated code which can be simplified. Now again, as I mentioned, there are two kind of overcomplications. Overcomplications in design and overcomplications in terms of implementation. Implementation is like simple logic, implementation logic. So both of them comes under overcomplication. Design overcomplication can be linked with scalability and maintenance, and there's a thin line between this thing. But implementation, which means logic-wise overcomplication, is unnecessary. You do that thing in DSA as well. That is the reason I'm telling you. For example, I have to find a factorial. Now, someone can write a code like this, which ultimately can indicate maybe he has written for cheating. Because if you are kind of copying someone else's code just to get rid of plagiarism, you might end up writing some gibberish, and that's what gibberish this is. So ultimately there's literally a lot of unnecessary code, and we can maybe abstract out that, or maybe get rid of that. So what we can do, we can simply get rid of that unnecessary code and write a very simple code for factorial. And this is very simple and straightforward. Now again, there can be reasons why you might actually do this. You might have to get rid of plagiarism. Maybe that's your use case. But if you are writing in general very complex logic just for some simple implementation, you are screwing things up. And again, this we do in DSA a lot, quite a lot. Now, what are the key features of KISS? Obviously, every good word, improving readability, ease of maintenance, lower risk of errors, because things are simple, straightforward, so it's very easy. Obviously, faster development, and it's easy to collaborate as well. It's much better and easy. Now, obviously, the thing which can come up that aren't how will I implement KISS? Simple, as we say, break down the problem into simple problems and then implement those simple problems. It can be applicable for DSA problems as well. Simple logical problems where you have tried the implementation, not the design, but the implementation. Break down to a simpler ones and then implement those simpler logics. Right? Next thing, please avoid over engineering. And again, this we saw abstraction as well, that you might end up abstracting. Let's say you have a dog, but let's say you have a business which is a dog firm, and you can just only have dog itself as a class, but still you will abstract as an animal class, then as a mammal class, and then as a dog class. It's unnecessary, right? It's overcomplicating it. Keep it simple. If you know your business is only for dogs, keep it only for dogs. Maybe you might say, Aaron, what if I get cats in future? Yes, if that's the case, then you can actually extend it and have abstractions in place. But again, it's totally up to the business. And that's as I said, there's a very thin line between over engineering and simplification and scalable code. Now, next, always make sure that you use clean or clear naming conventions, because you see that you might say, Aryan, I will write XY. Again, this is what you do in DSL a lot. Aryan, I will write XY, but you should write something like this, base price, total price. Why? Because you're keeping it simple. Now, simple not for you, but for others. For you, this is simple. Aryan, it is easy to write, but again, for others, it is hard. So for others, it should be simple, easy to understand. And that's the thing. Obviously, to make things simple, you can leverage design patterns as well. But obviously, there's a catch here that leveraging too much design patterns can make things complicated as well. But again, as I said, there's a very thin line to it. You can never know in which portion you are. Obviously, with following design principles, you will be writing more modular and maintainable code. Let's see an example of a simple piece of code where I'm just processing order and getting corresponding price for it. This is the final total price. You might say, Aaron, it is very simple, right? I have kept it very simple. Technically, it is simple, but for you, because you have done a lot of things here. You have found the total price, then you have found another price which is addition of the tax rate to it, and then giving a corresponding final price. Rather, if you would have broken down to subtotal price and then giving the final total price with adding tax rate, so that in future if anyone else wants to check, okay, what is the price right now and then after tax what is the right now, then they can just simply get the corresponding prices as and what they need. Again, this is not a very good code because you will see that the strategy of how the price or how the subtotal is being calculated, I've hard coded by multiplying it with some factor. Okay, they can be constant as well, and that's you will see that with the help of design patterns I can make it more scalable by using pricing strategy. Again, that's a design pattern which we will see later on, but again, as I saw that this is not a very clean code, but it is better than the previous code. Now you might argue that Aryan, it is more simple. True, but only for you. There's a catch. Simple for others. It should be simple, and as a simple, it should like anyone who reads it should be able to understand easily, and also should be able to infer what exactly is happening. I can simply say that okay, I have to find subtotal. I will go here, and again, this is not good to find a subtotal. I should have some pricing strategy which will say that this is how I will calculate any subtotal price, and then implementing the rate. So this is how you can go about it. Obviously, as we saw that what all things could be there are its advantages. Enhanced readability because you have better good looking code, good variable names, good function names, more modular, and obviously because of better code you have, it is much faster to debug it. And again, it will improve the collaboration because now everyone can use that same piece of bit and modify it, change it, use it. There are multiple things. Obviously, maintenance costs reduce because now the code is clean and much clear. Everyone can understand easily, and thus because it's simple, it's super simple. Everyone can understand easily. And if anyone thinks, okay, I can use this, yes, use this. If there's an issue, okay, correct this. It's easy to correct as well. And that's the best part about keeping a simple piece of code. And with that, the development time becomes very, very, very less because now things are very simple for you and for others. So you don't have to spend much time just understanding, giving that code to GPT, asking what it is doing. No, not required. You can simply, with a human read, can understand what the code is doing. Again, there are disadvantages. As I said, that there's a very thin line between overcomplication and doing something just for the scalable terms. So if you keep things like very simple, it might result in a design that cannot be accommodated in future changes. So you might say, Arun, I will oversimplify this. I will just keep it at one place. Yes, you can do it, but obviously this will end up having a very limited flexibility in terms of future modifications. And the same thing, you might end up oversimplifying a lot, and you might end up misinterpreting what I mean by oversimplification. As I mentioned, there's a very thin line, and people should assume this case as very thing. Okay, the code should be clean, clear, and modular. That is how you can assume this kiss pattern to be. Don't oversimplify things because this is not LLD interviewer is looking for. Cool. And obviously, because Aryan has said use kiss, keep it simple. Then I will not even innovate. I will not even use any design patterns. No, I will simply get rid of this. So please don't do that. So that's the thing that you have to make sure that you are using kiss, not just anywhere. No, I will keep kiss. Okay, this is the kiss. Okay, this is the kiss. No, keep it case like okay, the code should be simple for you to understand, for others to understand. That is the entire essence of kiss. Cool. Let's see you in Yagni. Again, this is also as redundant as kiss, as like not redundant, but okay, not that much useful, but still, let's see Yagni. Welcome to another illogical principle, which is Yagni. You aren't gonna need it. It simply says that you should only implement the features that are necessary for your current requirements, and please, please, please not add anything additional, any additional feature which you might think you might be needing in future. Now, there's a very slight distinction between not thinking about future and thinking too much about future. So again, there's a thin line, as we saw in kiss as well, that there's a thin line between what you should do versus not. So again, it simply says that the basic idea here is that adding unnecessary features, it can lead to complexity, very high complexity. Also, adding unnecessary feature will take corresponding time, arrangement of them, arranging them, placing them, organizing them, integrating them with the existing things, and obviously making more prone to bugs. Now, as we saw in the last section as well, that we have KISS. Keep it simple and stupid. Same way as YAGNI. That you aren't gonna need it. So keeping it simple and keeping the things which you are gonna need it and avoiding any unnecessary complexity is the entire essence of YAGNI as well. Which means it focuses primarily on giving the simplest solution which can meet the current requirement. Again, please, as we saw last time also, please don't take this a simple thing otherwise. It means simple in terms of design and requirement analysis. Now, for example, let's say we ask you to design a payment processor. This is a very, very, very basic and straightforward thing. Although in the future LLD, we will see a very complex stuff. In that, we will be discussing about everything. Bad code, good code, the way you have bad touch, good touch, same way. We'll discuss everything here. Now, we are asked to only have a requirement of debit card and credit card. That's it. This is what we are asked. And we have to focus on meeting these requirements which we have. So, what we should not do is thinking of, oh, I can have PayPal, cryptocurrency. Although you might say, Ari, but if I will not think, then technically I will not implement those, right? As in, I will not make it extensible, make it scalable. I should have that scalability feature, right? Yes, you can have that scalability feature, but you can also think of that scalability can be in terms of debit credit card. You can think of, but that thinking should be either very fast, quick, and also never implement, at least never implement it. So please make sure that you should not add any unnecessary complexity and not wasting time, as I told you in the last lecture as well, where we are discussing about interview techniques. We saw that time is very important currency in LLD, so make sure that we are utilizing time as much as possible. For example, if, as we saw, that we want to implement only debit and credit card, so it's unnecessary to actually implement your PayPal and crypto. Now again, although it's not a good code, you would be having a payment strategy instead. But again, the entire essence of showing this code is not showing you how a very well established code for payment processing would look like. No, it is not for that. It is primarily to show that unnecessary piece should be avoided at all cost. Although again I say that this can be much more betterly written with the help of payment strategy and again different design patterns which we will see in future. But the idea is, don't unnecessarily write code which the interviewer has not asked you. And again, trust me, people literally do a lot of things like this in an interview. They're asked one statement and they waste time on something else, which they think, oh, I'm making it extensible, I'm making it, I'm just showcasing that, okay, this can be like this, like this, like this. It is literally unnecessary and you will not get points for this. The task which is given to you, implement that task and showcase that task itself. Again, as I mentioned in the interview tips in the first lecture as well, you can tell, you can verbally tell, but don't even dare to write it down. You will literally waste your time and you will be done. Now, obviously you see that why this approach fails, as very simple, straightforward, that it is not following the requirements whatever I wanted. It is over engineering it, obviously wasting time in implementing it, obviously thinking as well, and giving the unnecessary piece of bit and complexity as well. Again, this is unnecessary, I'm saying. Also, you might say, Arun, it is good to showcase, right? Yes, it is, but not in an interview or not in a production code base. Now, what's the code which can be a little more better? Again, I said little more better in terms of YAGNI. It is following YAGNI. It is implementing only what is needed. Implementing only what is needed. That's it. Not much. Again, I'm saying that this is not a good code, but it follows YAGNI. That is the essence of it. Now, obviously, it will get the requirements done. It is much more simple. It also demonstrates YAGNI. So ultimately, as a key feature, if someone asks, you can simply tell, although this is not required, KISS, YAGNI, they are literally never used. You must only remember SALT. That's the main thing. Others are just, just fancy things, just, fancy terms which are given, never used, never required. No one asks about them, but yeah, it's good to know about them. So obviously, what we saw that the key features are, it prevents over engineering, it saves time and resources for us to implement it. Always the code is maintainable because there is a less code to maintain. We are not writing unnecessary piece of bits, and also we are following and aligning with agile principles. Just to summarize, YAGNI entirely depends upon the requirement, which depends upon what did the person ask you to do. So get the necessary requirements, discuss within your team whatever needs to be done, and then analyze and see what's the simplest plan. Again, when I say simplest, which is KISS, simplest plan for it, get it done. Again, requirement, YAGNI. Simplest plan, KISS, and then implement that simplest plan with the help of your solid and other design patterns. That is your actual stuff which you have to do at every step in your design cycle. Now, lastly, making sure that I'm promoting simplicity, unnecessary complexity, I'm reducing it, and also help my team focus on what is the main essential component and not diverting them, in unnecessary features. But it is very important for you to remember that there's a balance between misinterpreting Yagni as not even writing things, not even making things extensible, because people might say, okay, I would not even need PayPal. Let's say if I ask you implement debit card payment, you might say, Aaron, I would need only debit card, right? Why would I need a credit card or a PayPal or a cash? I will not need it, so ignore it. So only hard code, I will hard code this thing. I will not even make an interface of payment strategy. This is illogical. Think about it, but implement only this. That is the entire essence of Yagni. Again, it should not be an excuse of neglecting, any of the architectural considerations which you can have in your design. So there's a step which you should follow just to get the right stage. Now, I hope you guys liked it. If yes, please make sure the like target of this video is 250 likes. And next video will be coming soon as you hit that like target. Bye bye. Take care.